All right, hello class again. We're going to go into section 2.2 now. We've talked about linear equations and the standard form and how to identify a particular equation. We looked at how to solve for a specific variable, and now we want to go ahead and go into our next section, which is going to talk a little bit about y-intercepts, x-intercepts, and bring us more in depth into quadratic functions. So the very first thing we're going to consider is regarding what is a y-intercept. So if you look at my screen over here, it is the point that crosses the y-axis. Your coordinates are always going to be the point 0, -2. Your x value always has to equal 0. Your book actually refers to this as 0, b, but I always just say a number just so that you kind of understand the concept of a y-intercept. You'll notice the picture I've drawn. I've drawn an arrow to this point right here. This point is the point that intercepts the y-axis, and so that is called your y-intercept. Think about football. The point of interception is where the placement of the ball changes from team to team. It's the point that they cross and the value changes. So you can kind of look at that when you're trying to remember the y-intercept. Next is our x-intercept, just like the y-intercept, but now dealing with x. So it's the point that crosses the x-axis. Coordinates are always going to be number and a 0. Okay, now y is equal to 0, and you find your x value. Your book refers to this as a, 0. So your book is looking at every ordered pair as a, b, and then it just uses whichever letter represents the number. And I've drawn a picture again. This is your x-intercept, the point right here that crosses the x-axis. All right, so what's the point? Well, you can find the y-intercept value by plugging in x equals 0 and solving for y. So if I ask you, find the y-intercept, here's the function. You're going to plug in x equals 0, solve for y, and that represents your y-intercept value. If I ask you to find the x-intercept, you're going to take your function, you're going to plug in y equals 0, because you know that y always has to equal 0, and you're going to solve for x, and that tells you the point where it crosses the x-axis. So here's an example over here that I've given you. Find the x and y intercept of the following equation. Y equals -2/3 x minus 4. Okay? If I ask you to find the x-intercept, we know that the x-intercept is going to be equal to a number and then your y value equals 0. So when you're looking for the x-intercept, you got to plug in y equals 0 and then solve for your x value. Now, if you're looking for your y-intercept, you know that your point is going to be 0 and a number because x has to be 0 and then you got to find the y value. Okay? And so then you're going to have y equals -2/3 times 0 minus 4. Okay, you're going to solve each of these equations. You guys know how to solve for x. You're going to isolate x by itself. In order to get rid of this, I'm going to multiply by the reciprocal, so that's -3/2. Got to do that to both sides. -12/2 equals x, and -12 divided by 2 is equal to -6 equals x. Now, this is your x value, and if you're asked to write the coordinates of the x-intercept, the coordinates would be -6, 0. Okay? Now, looking at your y-intercept, pretty easy. This just turns into 0, -4, so your y value is equal to -4. So when you are writing the coordinates of your y-intercept, the x value is 0, and your y that you just found is -4. Super easy, pretty self-explanatory. Now, I tried to provide a nasty example. Not all of them on WebAssign will be this nasty. Some may be nastier. You may see some square roots. You may see some squares. I don't know. Whatever you see, the process is exactly the same. So don't allow yourself to get tripped up by notation. Solve it as you would any type of equation. All right, our next idea is zeros of a function, okay? The zeros of a function, let's see if I can get rid of this background. There we go. Zeros of a function are the points that hit your x-axis right here, okay? So I've given you some type of quadratic equation, okay? And in this quadratic equation, you have 2 points that hit your x-axis. Now, what I want you to notice, what does this point represent? What is your y value right here? It didn't go up or down, right? If you're talking about what's hitting on the x-axis, it's 0. What about here? Your y value is also 0. So what does that also equal? If your y value is equal to 0, and you're looking for the number, the x's, what also does that represent? Well, we have number 0, my x-intercept. Okay, so what does this kind of tell you a little bit about? Well, you may have more than one x-intercept. Okay, you may have several zeros. How do you know exactly how many zeros you have? Well, there's something called a degree. We're kind of jumping ahead. But the degree represents the highest exponent in a given term. And we're going to talk about this again in section 2.4. Okay, so if I give you x squared minus 2x plus 6, because your highest exponent is at 2, it lets you know that you should have 2 zeros. I don't know if you guys can hear all that racket, but my dog has gotten bored with all this snow and is finding every single thing that he can get into to get into. All right, now if we were dealing with a linear equation, on the other hand, a linear function does not have any exponents. It has a degree of 1, so you would expect to have only 1 zero. So that's kind of a way to just check yourself. Again, we'll get into that more in 2.4. Right now it's not so important, but just kind of to stay on top of it. All right, now this is a key point on how to find the zero. Obviously you told me it's just like the x-intercept, right? Because our y value is equal to 0, and then you're looking for whatever x value will go right here. So when you're looking for it, you're just going to simply plug in your value of 0 for y and solve for x. Now, there may be a situation where I give you a problem such as this one right here. I want you to verify that this specific number is a 0 of the function given here. Okay, so how are you going to go about this? Because I'm actually giving you a specific value to plug into your function. And I'm asking, hey, is this a 0? Is this in fact a 0? Well, this represents x equals negative 2. So for every x I'm going to see, I got to plug in negative 2. Notice what I did here. You know, for every video I have made, my phone has gone off. I should have put it on silent. I apologize, everybody. My family is continually calling me due to the snow to make sure that I'm okay. But anyway, so you see that I have put my number within parentheses. I've done that because the minus sign is not part of the negative that I'm verifying. You gotta be very conscientious of that, okay? Make sure you don't make that common mistake that people make. I'm gonna go ahead and simplify. And that's 8 minus 6, which gives me 8 positive 2. If I did that right, it appears right. Minus 6, 8 minus 6 is 2, okay? So I want to verify that this is a number that is a 0 of the function. Well, you know that f of x also represents y. So that's telling me that when I plug in the value negative 2 for x, the y value is equal to 2. Is that a 0? What did we say my y value had to equal? It was similar to an x-intercept, right? So if it's similar to an x-intercept, my y value has to be 0. Is my y value 0? Okay, so no, this is not a 0 of the function. Okay, let's look at another one. What about positive 3? Okay, f of x equals x squared minus x minus 6. And I want to verify 3. Try to work this one out on your own. After solving this out, I get a y value equal to 0. Is that what I wanted? Yes. Therefore, the point 3, 0 is a 0 of the function. Okay? Very good. Moving on, we're going to talk about points of intersection. Now, I feel pretty confident that you know what an intersection is. it's a common term. Intersection occurs on the road. Every single day when you get to a stoplight and you're looking at the crossroads between two roads, that's a point of intersection. In math, it's the point where two functions share the same value. So if you look at my picture here, this point right here, both of those lines share that coordinate point. They share exactly the same point. Okay? So that lets me know that is my point of intersection. Now, we can do this algebraically. Okay, finding points of intersection algebraically. These are your 5 steps. I'm going to give you a moment, or maybe you want to pause your video to make sure you record these down. These are extremely important as you're going through and solving all of your problems. All right, now we're going to look at an example. All right, so step 1 said, take the two problems, the two equations that you have. Okay, and you're trying to find the point, if there is one, to see where these two lines intersect. Now, it's a possibility that these lines might not intersect. When could that happen? Well, maybe they just never go near each other. Maybe they're parallel. Okay, so there are circumstances where they could not intersect, but let's assume that these intersect. Okay, we want to find the point in which that happens. Step 1 says to put both equations into slope-intercept form. You all know that slope-intercept form is going to have the form y equals mx plus b. M stands for my slope. B stands for my y-intercept. Good. Okay? All right. Negative 3y equals 6 minus 2x. I got to isolate the y, so that's going to be 6 minus 2x divided by negative 3. Now, a common question, can I go ahead and simplify 6 divided by negative 3? I hope you said no, because on the top, what's going on? An operation. What is that operation? Subtraction. And I've said about a million times, if there's addition or subtraction, you better not go canceling up and down. That's not allowed. Okay? So in this situation, we're going to leave it as is. No need to worry about simplifying that any further. Okay, our next one. All right, now we have our two equations in slope-intercept form. Now I'm going to actually pull up the steps from the page of 4. Okay, our second step says, set both equations equal to one another. Why can I do that? Well, I'm telling you that y equals this value and it equals this value. Y here and y there are the same exact y, correct? So if I set them equal to each other, I haven't changed the meaning of the problems, okay? But what I've done now is I've written it so that the only variable left is an x. And that makes it easy for me to solve this. You guys already know how to solve for x. It's a multi-step problem. First, I'm going to get rid of the fraction. How am I going to do that? I'm going to multiply out my denominator. Multiply the whole term by negative 3, and same thing to the other side. These are going to cancel out, leaving you with 6 minus 2x equals negative 12x plus 18. I'm going to go ahead and move my x over. That's going to be a 12x minus 2x equals 18. I'm going to move my 6 over. Simplify. 10x equals 12. And then let's solve for x equals 12 over 10 or 6 over 5. Okay. Now, then we kind of did step 3 already, and step 4 says use an original equation to plug in the x value you just found to solve for y. So basically, you need to find y. Now, I said an original equation, but you can actually use the ones where you set it equal to slope-intercept form. I personally think it's easier because you're solving for y, so why not use the equation that is already set to y? Also, either equation is fine. Pick whichever you want. I recommend picking the easier one. This has a fraction. My x is a fraction. I personally don't want to use those. Fractions within a fraction, that makes me not excited. Okay, so I'm going to use the easier problem over here. I'm going to go ahead and do that in another color. I'll do this in black, just so we don't get confused. Let me draw some lines. I don't want this to look a little too confusing for you guys. Y equals 4 times x, which is 6 over 5, minus 6. That's 24 over 5 minus 6. And let's see, I'm going to have to do this by hand. I apologize. I don't have a calculator beside me. I'm going to make like denominators. That would be times 5. That would be 30. So we're going to have a negative value. This is 24. So y equals negative 6 over 5. I believe my math is correct. I apologize if I'm incorrect, but I'm pretty sure that's right. So now I found my x value over here. I now found my y value. So the point that these two lines have in common, where they intersect at, is the point 6/5 and -6/5, my x and my y value. Okay, and that's how you find the points of intersection. Now it's kind of cool because you can actually do this graphically as well. It's going to be a little difficult for me to explain that on here, but what I want you to do is to go ahead and go into your calculator and go to y equals and type in your two equations. And once you've done that, I want you to go to second calc, or that's also second trace, however you look at that. And then I want you to go to number 5, which should say intersection. And after that, let's see what's next. Number 5, intersection. It's going to ask you, it's going to take you to your graph. And it's going to say first curve. And it's going to have a little blinking dot on one of your lines. And you're going to press enter. And then it's going to say second curve. And the blinking dot should be on the other line. And you're going to say, yep, enter. And then it's going to say, do you want me to guess this? You're going to say, yep, enter. And then it's going to give you your x and y value. I believe the decimal form is 1.2. So you should have 1.2 comma negative 1.2, okay? And I will talk more in class about how to convert that into a fraction, because I know your calculator does allow you to convert that decimal into a fractional value. Okay, and so with this, I'm actually okay with you using your calculator, but I do want you to know how to do it algebraically. I highly recommend you when you're doing your homework to do some algebraically, because on the test there will be questions that say find the intersection point algebraically. This time I will be specific. Not a whole lot, but there will be some questions like that, and so you'll need to be able to know how to go about that. Now, if I say find the intersection point and I'm not specific, then by all means use your calculator. It's fine by me. I want you to use the resources that you have available to you. Again, on your homework, don't go and solve all of them algebraically. You're welcome to if you want, but I don't think there's a need to. But do enough to benefit yourself so that you feel comfortable with finding it algebraically. Don't rely on your calculator because it's not going to help you prepare for the test, okay? On the screen, you'll see your homework omit questions. If you have any questions, concerns, please email me as usual. And this homework will be due Sunday at 11:59 p.m. All right? Stay warm.